Hello everyone and welcome to this video on graph representation and traversal algorithms. Graphs are an essential concept in computer science and are used to represent complex relationships between objects. In this video, we will be discussing how to represent graphs and how to traverse them using two popular algorithms, BFS and DFS. Part 1. Graph representation. First, let's talk about how to represent a graph in computer science. A graph consists of a set of vertices and edges that connect them. There are two popular ways to represent a graph: adjacency matrix and adjacency list. An adjacency matrix is a 2D array where each cell represents the connection between two vertices. If there is an edge between vertex I and vertex j, the cell I, j, will be set to 1, otherwise, it will be set to 0. This representation is useful when the graph is dense, meaning there are many edges. An adjacency list is a list of lists where each sublist represents the connections of a single vertex. This representation is useful when the graph is sparse, meaning there are few edges. Part 2. BFS Algorithm. Now, let's move on to the BFS algorithm. BFS stands for breadth first search and is used to traverse a graph in a breadth first manner. It starts at a specified vertex and visits all the vertices that are reachable from it. The BFS algorithm works by starting at the specified vertex and visiting all its neighbors first. It then visits the neighbors of those neighbors and so on, until all reachable vertices have been visited. The algorithm uses a queue to keep track of the order in which the vertices are visited. BFS is useful for finding the shortest path between two vertices in an unweighted graph. Part 3. DFS Algorithm. Finally, let's talk about the DFS algorithm. DFS stands for depth first search and is used to traverse a graph in a depth first manner. It starts at a specified vertex and visits all the vertices that are reachable from it. The DFS algorithm works by visiting the specified vertex and then recursively visiting all its neighbors. It continues to do this until all reachable vertices have been visited. The algorithm uses a stack to keep track of the order in which the vertices are visited. DFS is useful for finding connected components in a graph and for solving problems that involve backtracking.